All right, let's talk about a design pattern that is turning slow, plodding AI agents into some seriously fast problem solvers. If you've ever wondered what makes one AI feel snappy and another feel, well, sluggish, you're about to find out.
So let's kick things off with a feeling I bet we've all had. You give an AI agent a pretty complex task, maybe researching a topic, and then you just wait. And you wait. It really feels like it's thinking one single step at a time. So why is that? What's the holdup?
Well, the root of the problem is something we call the sequential bottleneck. Think of it as a one-track mind approach, where an agent absolutely has to finish task A before it can even think about starting task B. Let's really break down what that looks like in practice.
Okay, take a look at this workflow. The agent finds the first source, right? Then it has to completely finish summarizing that source. Only then, once that's all done, can it move on to search for the second source, and then summarize that one. Every single step is chained to the one before it, which creates this slow, step-by-step march to get to the final answer.
And this, right here, is the heart of the issue. The math is simple, and it's not in our favor. It's like a one-lane road during rush hour. Every car, which is like every task or every API call, has to wait for the one in front of it. The total time just keeps adding up, creating a massive traffic jam. But what if we could build more lanes?
Well, it turns out we can. And that brings us to the parallel solution. This is the design pattern that just blows that bottleneck wide open. It lets our agents think less like a single overworked person and more like a highly efficient team.
So, the core idea here is called parallelization, and it's pretty much what it sounds like. It's a pattern that runs multiple independent tasks at the exact same time. And that word independent is absolutely key. We're talking about tasks that don't need to wait for each other to get started.
This slide, I think, visualizes the concept perfectly. Instead of one agent doing all the heavy lifting, you have a parallel agent that acts like a project manager. It takes a big request, breaks it down into smaller jobs, and then delegates that work out to a bunch of specialist subagents. And they all get to work at once, so the results come back in a fraction of the time.
So let's just nail this down. Sequential is like a single worker on an assembly line, building a car piece by piece. Parallel, that's like having a whole team of specialists working on the engine, the chassis, and the interior all at the same time. The difference in speed is just enormous.
Okay, so this isn't just some cool theory on a slide. This pattern is already out there, in the wild, powering some of the most responsive AI applications you can find. Let's look at a few examples.
I mean, the applications are just everywhere. For information gathering, an agent can check the news, pull stock data, and scan social media all at once. For data processing, it can run sentiment analysis and keyword extraction at the same time. It can even generate different parts of an email, the subject line, the body, the call to action, all in parallel. Every single one of these use cases gets a massive speed boost.
Let's use that travel agent example to really make it click. Imagine you ask an AI to plan a trip for you. Instead of sitting there waiting for it to find the flights, and then search for hotels, and then look for cool events, a parallel agent does it all at once. You get a complete travel plan in about the time it would have taken the old sequential agent to just finish step one. It's a game changer.
So, you might be wondering, how do developers actually build this stuff? Well, it's not magic, it's baked right into the tools they use. Let's take a quick peek under the hood at how two major frameworks, LangChain and Google's ACDK, handle parallelization.
So in the LangChain world, it's all about bundling. Developers can group a bunch of independent tasks, like, say, summarizing a topic, generating questions about it, and pulling out key terms, and stick them all into a single dictionary. The LangChain engine is smart enough to see that bundle and knows to execute everything inside it at the same time. Super clever. Now, Google's Agent Developer Kit, or ADK, thinks about it a little differently, more like building a specialized team. First, you define your specialist agents, maybe one for renewable energy, another for electric vehicles. Then you put them under a parallel agent, which is the manager who tells them all to start researching at the same time. And finally, a merger agent comes in, takes all their individual reports, and weaves them into one cohesive answer. It's a really elegant divide and conquer strategy.
Okay, let's zoom out and land the plane here. We've seen the problem, we've seen the solution, and we've seen how it's built. So what are the absolute key things you need to walk away with from all this?
First, let's talk about the problem again. A purely sequential process is just a natural bottleneck. It's that simple, especially when an AI has to wait on outside things, like fetching data from a website.
Forcing everything into a single file line is what creates that frustrating lag.
Second, the solution. Parallelization is the answer, because it totally rewrites the rules of waiting. Instead of adding up all the time, your wait is now just the time it takes for the single longest task to finish. That shift in the math is what just slashes the total execution time.
And finally, here's your rule of thumb. If you're ever designing a workflow and you find yourself saying, okay, the agent needs to grab data from API A, API B, and API C, and none of those tasks depend on each other, that is your green light. That is a perfect candidate for parallelization.
So, to wrap it all up, parallelization is an absolute game changer for efficiency. But, and this is important, it's not a free lunch. It does add a layer of complexity when you're designing and debugging these systems. The good news, though, is that modern frameworks like LangChain and Google's ADK are giving developers powerful, ready-made tools to manage that complexity.
And that leaves us with one final thought to chew on. As the tasks we ask of our AI get more and more ambitious, pulling from more data sources, using more tools, taking more steps, is parallelization just a nice-to-have optimization anymore, or is it actually becoming an absolute necessity for building the next generation of truly intelligent agents? Thanks for tuning in.